I'm Liwei from National Yangming Jiaotong University based in Taiwan. I'm very excited to share our research on LapTouch using the lab for seated touch interactions with head-mounted displays. Let me start with this small demo. So this is a wake-up mode directly using the lab. So in this work, we're talking about seated interactions, which I think has not received enough attention in past research, especially when head-mount displays are going to be part of our everyday life in near future. Speaking of seated interactions, one can use controllers. However, it is annoying to carry controllers around and they are forgettable. A mid-air touch interaction does not need additional device, but it can be tiring for longer-term use, which is known as gorilla arm syndrome. Actually, our body offers such touch interfaces anytime and anywhere and can keep the interaction intimate to our body within the one's personal space. Many research has been investigated the so-called on-body touch interface, such as using the finger, the palm, or the arm as touch interfaces. And we found the lap, the front side of the thigh, is particularly interesting body portions for deploying touch interface when we are seated. It affords a surface that is spacious, smooth, easy to access by hands for touch interactions. And many occasions in a day where the lap is in close range to our hands, and this would make the use of the lap as touch interface a very useful way for interactions. I gotta talk about the LapTouch. We provide three ways of using the lab interfaces. They are direct touch, indirect touch, and eyes-free touch. In direct touch, the interface is directly laid on the user lab, meaning that the user has to look at the lab to see the interface and perform touch on it. And for indirect touch, the user sees the interface in front of him while they will touch the corresponding region on the lab to perform touch interactions. Both the direct and indirect touch interfaces offer visual feedbacks which can guide user touch if their initial touch was not precise. And we also explored the eyes-free touch interface, where the interfaces would appear in front of user too, and the user touches the corresponding region on the lab to perform the touch. However, there was no visual feedback given to the user guiding their touch, meaning that user has to rely on their proprioception and the skin feedback on the lab to determine the touch location. To our scientific interest, we want to know the limit of touch precision on the lab using only the proprioceptions. I got started with study 1, which compared direct and indirect touch. So direct touch with visual feedbacks. The participant gonna see the task appear as a green patch on their lap and the two cursors representing their hands and guiding their touch. Let's see the video here. So the two cursors are for the left and the right hand in air. Users use them to guide their touch, completing the task appearing on the lap. And for indirect touch with visual feedbacks, the interfaces for indirect touch would appear in front of the user, so the user doesn't need to neck down, but they're just looking in front to see the interface to touch. And every touch on the lap will have a projected hand cursor appearing in the corresponding location of the interface in the front, so that would help then completing the touch. So let's see the video here. So basically, the user will see the interface in front and the task appear as a green patch as well. And they will touch the lab first using the proprioception sensing. And then they will see the projected cursor. It's not so visible, but they can actually quite easy to see in VR. And that would help them, the projected cursor would help them completing the task properly. The results. And this figure shows the accuracy of direct and indirect touch across different layout densities. Generally, we see a quite good performance here, but if we look at this 95 accuracy standard, we will spot 3 cases that do not reach the 95 standard here. And they are all direct touch, and they only happened at high column layout here, the 5 column layouts. And we realize that this is because the high slopes of the lab on the 2 sides would lead to the low visibility of the visual feedbacks during the direct touch interactions. I'm going to jump to the result of subjective experience in terms of confidence, convenience, and willingness to use on different layouts. In a nutshell, we consistently identify that 4 row layouts and 5 column layouts are worse than the other lower density layout in terms of user experience. And with that, I'm going to summarize the study 1 finding. We have to skip many contents because of time, but most importantly, in terms of accuracy, the direct touch can support up to 4x4 layout, while the indirect touch can support more than 4x5 layouts. But considering subjective experience, that 4 row and 5 column layouts should be avoided. Taken together, we recommend that 3x4 layouts are preferable and more effective in terms of accuracy and experience for both direct and indirect touch interactions. Now we can talk about study 2 for eyes-free touch interaction without visual feedbacks, which means that users have to determine their touch location using only their proprioception and skin feedbacks on the lab. As you can see, the result generally is not good. None of the layout here can reach to the 95 accuracy standard. Just for brevity, we applied the general SVN, which boosts the participant performance to support up to 2x2 grid for 95% accuracy. But if we use personalized SVN, which means users gonna contribute their data a little bit, then we can boost their performance to support 2x3 or 3x2 layouts. For conclusion, we propose LapTouch using the lab for seated touch interaction with head-mounted display. Our study suggests that for direct and indirect touch, a 3x4 grid is recommended in terms of both accuracy and user experience. As for the eyes-free touch, with the support of personalized SVN, user can reach up to 2x3 or 3x2 grid with 95 accuracy performance. Yeah, thanks. With that, I'm happy to take questions.